Today, I'd like to talk about mobile development at Mercari. My name is Touhara Hideaki. My Slack name is Hide. I joined in April of 2019 as an iOS engineer. I'm in the team called CX BlackBerry right now, so I work on transactions as well as my page, and I'm an engineer working on those areas. Let's start with today's contents or today's agenda. First, I'd like to go over the mobile development cycle, do a quick overview about how we do development for mobile. And then in the second section, I'll go into detail for each phase. And in the third part, I'd like to introduce some of the tech stacks we use within mobile development. For today, our goal for this presentation is to make sure that all attendees who are here know about have an understanding or an overview of the mobile development cycle. In addition, we'd like to make sure that you can look at UI components and be able to find related code base corresponding to the iOS app UI. In terms of non-goals, this presentation is not to make sure that you're understanding all the details of iOS development and code base and the code base, as well as I won't be covering how to add new features and things like that. Next, I'd like to jump into the overview for the mobile development cycle. Now, what does the development cycle look like for mobile devices? First, PMs work on creating a spec document. Then the designer will work on the UI design. And with those two components, the engineers will work on creating a design doc. Not for everything, but if it's over a certain scope, then generally a design doc will be needed. Then members will create tickets and adding a little bit more granularity to the tickets. Planning refers to, for example, you might have already attended a Scrum DevDojo, but basically this refers to sprint planning. So estimating tickets and taking what was estimated and deciding how much of it will be part of the sprint. The next step is to write code and create PRs. After that, we have dogfooding and QA. These are somewhat similar, or the objective is similar. With these steps, we want to make sure that we are doing quality control, that everything is working and functioning the way we hope it to. And finally, we release the feature and then monitor the feature to make sure that no major issues are occurring. And that is just a summary of the review, but I'd like to go into detail for each phase. The first here is creating a specs. Generally speaking, PMs are in charge of doing this. And most people use Confluence to create specs. At this point, client engineers are the sort of counterpartners to the PMs on the engineering side. So they might share their opinions. They might review it if the document is already done, raise any concerns, share thoughts. What sort of comments or feedback should you share? Let's say you look at the spec doc, you might comment on how feasible it is. Or let's say this implementation might be easier than what is being proposed. What do you think? If engineers can share their opinions and feedback at this point, I think the next phase should go much smoother. In the next step, The next step is to create the actual UI design. Most teams at Mercari use Figma. When the design is complete, what do client engineers do? Or where do they need to check? This is just an example, but first, transition ways, let's say push notifications, full modal, half modal, when only half of the half is displayed. So when a new display is shown, what should it look like? In addition, engineers might check about the design system and if the it follows the design system that we have. Or let's say it doesn't exist within the design system, and so a decision needs to be made about standardization if it needs to be added. And what I think is most common is to consider errors and or error handling. For mobile devices, there are multiple ways you can show errors. For example, it's a full screen display for an error, or a dialog pops up and there's an error there. If you tap on it, then the error disappears. For a ground up, having a little screen pop up from the top and disappear over time, or something that's not an error, say, but let's say what happens when a list is left empty or it's not filled out properly, what gets returned. These specifications need to be clear when we create this design, because then uh, it'll be difficult or time consuming in order to check all the edge cases later. For iOS and Android, there is a review at release, and so we might need to check platform specific items. Other items, let's say, related to code that need to be checked about the code base. If those concerns are shared beforehand, this process also becomes smoother. Next, once the design and the specification document is done, we move on to the design doc. This is written by engineers. If it's a really small feature, then there may be cases where we don't actually prepare a design doc, but design docs give you an overview. For example, in my team, we combine it between iOS and Android, and how you might add information about how you'll change which code specifically. So, depending on the team, the project, whatever the group might need at the time, the design doc uh, gets updated or changed. In the next phase, after writing a design doc, making sure that everything is clarified, most teams use a Scrum cycle. So, using that, the, the teams will create tickets and then plan according to sprints. I think that's quite general, see what happens in the organization. For tickets, there's a hierarchy. We mainly use epics, stories, and tasks. An epic ticket is the root ticket for a feature. It tends to be one item for that feature. And then for each epic, there may be multiple stories or child tickets that come from this epic. So stories and tasks. Story tickets are basically about user story tickets. So one function from the perspective of somebody who's actually using the app is how we think about stories here. Tasks sometimes are independent from the stories, But stories tend to be a unit measured by the perspective of somebody who's using the product. But if we continue to use that perspective, the story tends to get too big. There might be multiple tasks, but in order to divide the story into a little further, divide it a little further and add a little bit more granularity for those who are actually working on the development, they might divide it into tasks. Next, we move on the coding section. So engineers write code and create pull requests. Regarding CI, mobile side uses CI as well, unit tests, UI, as well as snapshot tests. So unit tests are regular tests, but for front end, you might need UI tests and snapshot tests. A UI test, I think engineers don't often write UI tests per se, but QA team engineers tend to write UI tests and manage them. More specifically speaking, mobile engineers, they add identities to each component or UI component, and using that identity, QA team will actually write tests for those components. A snapshot test is essentially you might set a scenario or define a scenario or what the condition is or the parameters for each screen. And then for the snapshot test, according to the scenario, it'll take a screenshot. And for iOS and Android, I think there are multiple sizes. And so depending on the size, it'll take a snap for each size. And if there's a difference between the master and the working branch, then it will detect that for you. It's kind of like a UI test, but it will do a direct detection. So it can check the size of the screen, but also, for example, accessibility, like dynamic font. At the OS level, you can change the size of the font. But let's say we make the text bigger. Um, Sometimes the text gets cut off, and the snapshot test can check for that. Down here, it says distribute to employees. But for mobile side, we release dev things to dev. So if we need somebody to to check it for you, somebody else to check, the build will automatically be made, and you can ask somebody to check it. Next, this is the branch strategy that the mobile team uses, but we use a trunk-based development style for branch management. And the master branch is always ready for release. And we try to keep pull request sizes small and merge quickly, one after the other. So what is the opposite end of the spectrum for that? So you create a feature branch from a master branch, and then merge everything to the feature branch. And once everything is there, and you don't merge to the master until everything is ready there. So that is kind of what we use happened in the past. But now we use small units and merge immediately to the master branch. And in order to cover new features or dangerous code, we use feature flags, and that will make sure the master is stable. As long as it's covered by the feature flag, there shouldn't be any impact on the production environment. So that is our current branch strategy. Once the development for the feature is complete, the code review is complete, we move on to dog fooding. What it's called may be different according to the team. But for example, in our team, once every 2 weeks, we get together and look at the features that we created within that sprint or the changes that we implemented, and we actually dog food or we check how it works and see what sort of feedback we have from the team. And if we have a test case by then we can check the test cases too. So these are sessions where you can check actual features. So engineers set dog fooding sessions, and once that's through, we move on to QA. QA stands for quality assurance. That does not equal manual tests. QA is not just about doing manual tests, but making sure that the quality of the product is ensured. So it's not necessarily just manual tests, is what I'd like to emphasize. What do QA members do? They are mainly responsible for writing test cases, and at times engineers do write test cases, but QA members may review them. The quality control is of course the responsibility of mobile engineers. They do dog fooding. We do dog fooding. We may write test cases too. And there's a service called TestRail. I honestly don't use it, but tools that different teams use, different teams use different systems or tools, but this one is sometimes used for managing test cases. So depending on the team, you may use a different tool. Now we move on to release. We do releases once a week. First, we cut the release branch. For iOS, it's 4 p.m. For Android, I don't know if it's at the same time. For Android, for iOS, I think it should be Wednesday at 4 p.m. The release branch is automatically cut. And with this, there's a release judgment test that's the QA team's responsibility. And so doing a check on existing features and making sure that there are no issues. If it passes this test, then it gets submitted to each app store. For iOS, it would be the App Store. For Android, it would be the Google Play Store. And each platform has its own review process. And it's possible to be rejected by the platform. And if that happens, we receive feedback and we need to fix it. Sometimes there are items that need to be negotiated, like please change this, or you're misunderstanding this part, or there might be sort of discussion there. Once we need to work on everything until the platforms accept. Next, I'd like to talk about tech stacks. The first feature I've already mentioned this, but this does not equal A/B tests. But on the backend side, there's configuration, and whatever's set there is read by client side, and using that value, we switch what is displayed. For example, for A/B tests, let's say there's a function called A or feature called A, and we're going to release that. Let me start again. Let's say there's an old screen and a new screen or display. Let's say we want to keep both, and we want to see which display would be better for our customers. Let's say from a GMV perspective. You can use this A/B test sort of function to test that. So feature flags also receive logs, and we use Laplace log for that. And those in the analytics team, for example, will analyze this information and then make a decision. Okay, maybe the new display is better. There are other ways that we can use feature testing. We use it for risk hedging. Let's say refactoring. Even if it looks exactly the same, if we want to rewrite the code or we want to swap out an old and new file, I think for refactoring, usually you replace all the old files with new ones and then do a release. But since we're using feature flags for development, we wouldn't delete the old ones. We just add the new ones and then switch out the displays using the feature flag function. And then we can compare A and B. And if there are no issues and we can establish that there are no changes there, we go ahead and refactor. And once there's a go, engineers may delete the old code and make sure that it's deleted. So keeping all the code for within the feature flag or just code accumulating, that is something that generally shouldn't happen. So within our team, I talked about using trunk-based development. And for that, we also use feature flags. And so for all changes that are made, we cover everything using the feature flags and then merge them. And so until development is through, the feature flag should not be enabled. And so even when it's in the production environment, it shouldn't be displayed. And so combining these two, we are committed to a data-driven development process. So you create a feature, add some variants, make sure that you're integrating an appropriate log for analysis. And then when we do new development, we don't decide things like, oh, this doesn't look very good, but we can actually take a look at logs and data, not just your perception, to make a decision on what features should be kept. And that is why we use these two functions. Next, this is about networks. Basically, for the client and the server communication, we use JSON and protobuf for HTTP requests and responses. And when it comes back as a JSON, it tends to be for legacy endpoints. So that means endpoints that haven't been made into microservices yet. So those tend to be JSON, and those that have already been transferred to microservices, it tends to be protobuf. For legacy endpoints, they tend to come from Mercari API or Mercari API something. Between JSON and protobuf, on the client side, definitions as well as how they are used are slightly different, so I would take that into consideration within development. So it's important to read back-end design documents too. And it's best for back-end side to also write design docs with the assumption that client side engineers are taking a look. We don't use gRPC for client. We use protobuf. Recently had discussions about using gRPC more, but at that time the discussion ended in going against that. I don't know what will happen in the future, but for now we don't use gRPC for client. So that is regarding the network. Next, I'd like to talk about design systems. A design system is something that provides a consistent UI design style across the company. So there's a style guide. You can see elements, what colors we use, what buttons or each component should look like. And within the code, client code, as well as on Figma, as long as these are defined, we should be able to provide a consistent or standardized design. And all of these components or layers can be added together to create a consistent style.